Being recorded.
Okay, welcome everyone to this week's OMR Architecture Meeting. Today we have one topic on the agenda, and it's a compiler topic. So we're going to be talking about issue 4518, make target environment local to the compiler. So I'll turn it over to Elton, or to Erwin, it's an in-joke, to take it away.
Okay, so to give background, the motivation for this came from OpenJ9, where I mostly spend my time. It started off with the fact that in OpenJ9 we now have multiple SDCs, and actually it's even before that. It has to do with the fact that now Docker, and the fact that people want to put an SDC in a Docker image and ship it. If you build the Docker image and populate the SDC on one machine and try to run it on another, depending on how you populate the second one and try to run it back, you can run into weird static compiler-like issues where the validations for checking the processor features are not exactly complete. For the most part, it's overly conservative, which sort of defeats the purpose, in that it will not load code that you want to be loaded. Basically, the relocatable code does not target some base set of features or whatever features are specified on the command line. And so when I first opened up this issue, I sort of figured we may need the thing that I'm talking about in this issue, but on OpenJ9 we may not necessarily need it, but I sort of figured it's worth bringing up anyways, because if we go down this road, it still helps OpenJ9 as well. The idea here is that the target environment in the compiler and singleton is a global, and there's also a host, which is used to sort of answer queries about where the compiler is running versus target is where the jittered code is targeted to run. In OpenJ9, we have the ability to generate relocatable compiles dynamically and optionally. And by that I mean the AOT compilation actually happens in the process, and the runtime can decide if it wants to do a relocatable compile. So the problem there becomes, if the target is global, then the target processor features you're targeting has to apply for both JIT and AOT compilations. And so I opened this issue to sort of discuss in OMR whether it's feasible and whether it makes sense to maybe have the target at compilation local, or at the very least have the ability to have different targets that a particular compilation can choose from, depending on how it's set up. So it's more discussion than anything else. When I first opened up the issue, I actually started modifying the code, and there's a lot of places, and it's not a simple search and replace. So it's definitely something that, if we're going to do the effort, we should figure out if it's worth doing.
Okay, so just a bit of a history on the compiler environment structure. So the intent there was to begin to redesign the way that we are, so traditionally we've used this sort of front-end structure to describe interactions with the VM and interactions with the, or front end, or interactions with the environment to ask certain questions. I guess early on in the OMR days, the way that we were approaching this was to kind of replace a lot of the front-end functionality with this sort of environment. And that work had sort of started and then stopped when things got really hard. And but there is a lot more work that needs to get done there. The front-end interface still exists. Since that time, thinking has kind of changed a bit from when that work was done to try and resurrect some of the front-end capabilities and make it more, make it less of a statically polymorphic hierarchy and a little bit more dynamically polymorphic, kind of like the way the front end currently is, because it needs to support things like different compilation threads can have different kinds of environments with them, right? So you could be doing an AOT compile, for example, on one thread. You could be doing a non-AOKT compile another. You could do the service compile, something like that. So there are different requirements there. So thinking was to actually go back toward a more dynamically polymorphic hierarchy. So none of that has actually happened yet. I am somewhat in favor of a per compilation thread environment where there are questions that compilation thread can answer that's specific to that kind of compile that it's doing. So all of those three apply. It could even at some point be like a cross-compilation thread, right, where it's answering questions about a completely different target than the host that you're on. But outside of that, though, I still think that and this is how the code is used in not only OMR, but also OpenJ9, there are questions that are being asked of the front end for the compilation environment, but more so the front end, outside of any compilation thread. And so the assumption seems to be that there is this sort of a dummy front end that's created, like a headless front end that's created that can answer those kinds of questions. So if we were going to go the path of actually having per compile thread environments, then I think that we also need to figure out what are the questions that are being asked, that could be asked outside of those per thread compilations, and sort of have those as part of, make those you ask the global environment those questions, and everything else that pertains to a particular compile, you ask the one on the compilation. So that's kind of the way I was thinking about it going forward, but zero work has been done on that yet.
So the way I was looking at the compiler and singleton, there was both the target but also the host, and the host feels like it would solve that problem, which is you need to ask the global front end question. It's probably the host that you want the answer to, right? Whereas if you ask a question of the target, then they could to have the notion of, well, some questions are always going to be true of the target. You can't really know which questions can be global. The questions that can be global can only be questions about the host, I would assume, right? In the broad scheme of things, and when I opened this issue, I was specifically looking only at tier target. There's other questions, like there's the OS, there's the object model. All those things could technically be, well, the object model could be different than what I'm running in. It's what I'm targeting.
Yeah, so, I guess the other thing is whether or not you were going toward a recompilation approach. Like, are you something that would eventually support recompilation, or something that's not that isn't quite support recompilation? It supports different targets, but not really a recompilation thing. Like I think your motivating example is you have different processor features, but it's the same architecture, like the same bitness and everything, right? But different features might be enabled or disabled on certain.
Yeah, because the initial motivation was like the static compiler-like problem, where like GCC emits, for a base compiler, unless you specifically say I want you to use features that I know are available on this processor. Yeah, is more or less the notion that I was coming from here. I was looking at it going, there are questions here like I mentioned the object model and all other stuff, where you could technically say, I want you to compile for a different object model, but I didn't want to, that's a much bigger scope, right? I sort of figured if we started the target process. Well,
that would be moving, so then that would be moving.
Compilation.
Yeah, you're moving a lot of the, or this is a compile server that can handle different kinds of.
Right.
Which ultimately, you might need to be able to support something like that, right? But
there's a halfway step on that way, which is where you're targeting the same environment, but you wish to selectively allow yourself to use or not use particular capabilities of the underlying hardware.
Mm-hmm.
And that's the baby step that OpenJ9 is most interested in at the moment, right? Because at the moment, we query the processor that you're running on.
Mm-hmm.
And if your processor says that it supports feature X, and we have the capability to use feature X, we will use it. And there is pretty much no way to stop that from happening, right? Short of hacking the compiler, right? If it answers yes to the capability, it'll use it, right? Or if you're on Z or you're on P and the architecture responds, Power 9 or whatever, you will get whatever exploitation we have for Power 9. There isn't an easy way to say, well, actually, you're running on 9, but what I really want you to generate is the code that would run on 8, right? The subset of the ISA that was on the previous generation. So even outside of all of the bigger environment issues, there's no configurability in the code gen really outside of any kind of debug options that people have sprinkled around to forcibly enable and disable capability.
So if that's the goal or the short-term step, then that would almost mean that we move a lot of the questions about the capabilities into a target that can be changed.
Yeah, so that's actually not super hard to do. It's just, because the target, if you look at the actual target object, it's a bunch of words, and the copy construction is super simple. It's just bit fields for the most part. So like you make a copy of it in the comp object, you just construct it in place and then modify it as you want. It's actually not hard to do. The work comes from the fact that it's not a simple search and replace, because now it will become comp arrow get target, for example, or get target end. But how you get the comp varies in the different parts of the code. Sometimes it's CG arrow comp, sometimes
You can always use TR comp.
Yeah.
well, I heard that's bad because it's always TLH, right? And for the most part, other parts of the code already has access to the comp via CG. It's just, it would make no sense to have one line that doesn't have TR comp, right? It's just tedious. It would be like a couple of hours of work. It's just, didn't want to go down that road and then realize it's not what we want to do.
I think most places you can get access to the compilation object. But most places when the compiler, you can get access to the compilation object through various means.
Mm-hmm.
The tricky parts, at least one I've seen, are actually like an AOT runtime, where it's not obvious, at least to those that aren't go through that code very often, that you actually can derive the compilation object from various things. So in those cases, you can maybe use trcomp, but
Yeah.
Or the places where we query the environment outside of a compilation. I don't know where we do that, but
There's a couple of places. So for example, with the opcodes, it figures out the size of the immediate or something, and that's a static. That's done once. That's done outside of a compile.
there is some stuff that's done like during the this is an OpenJ9 specific thing, but there's things that are done like by the either the patching runtime or the sampling threads or things that get called by the various hooks, like for class loading, class unloading, all that kind of stuff that actually gets invoked by the hook mechanism, and you ask for the front end to do one thing or another. Mm-hmm. But it's the front end that you get there, I think, comes from git config, which is just some generic front end that gets cooked up at some point that's capable of answering sort of these global questions.
So that's sort of why this one was just targeting specifically CPU features, because like when you start getting to front-end questions, it gets harder to sort of. Yeah. Whereas CPU features are like usually things that query in the JIT and stuff don't ask about, processor features and whatnot, right? It's a smaller step to take, and then the bigger question becomes, like for example, what you're saying, whether you want to go down the front-end route or something else that's front-end like, or.
Mm-hmm.
So, I mean, we could have a bigger plan for the different steps you want to take.
So all the processor, I don't think it's true that all the processor feature queries that we do at the moment go through target.
I think almost all of them do.
They do?
Well, part of Aiden's work is to make that true.
No, but even the ones that, like, so even in the compiler, it always goes here target dot CPU dot get something, right? So it actually.
So in x86, for example, if I want to ask if AES supported or are the TSX instructions.
Those are off the code gen, but then the code gen gets it from the.
But I think what it gets Isn't what it gets from the target is just the CPU ID, and it picks out the bits that it wants.
Yeah. So, but like basically, it gets it from the compiler, the target, and so even in the code gen, it first gets the target end, and then like caches it locally.
But it's getting the bit. It's just getting the bit.
Right, but you can toggle it. Like the point is, while that's a set of bits, and we take the set of bits from the processor, there is no reason that you could not dork those bits
Get
on
a
and
separate
off.
set of bits for.
Yeah.
Right.
That's sort of I already did one step of that already that Andrew merged, which was I own like whatever bit CPU ID gives, I actually mask out the bits the compiler doesn't care about. So we pretend like we only see these bits. Really, you can see more, but to help relocatable compiles, it just happens like that's not enough because you want to be able to.
That was done just so that if you start looking at a new flag, you get an assert that warns you that you need to update the relocation infrastructure to account for the flag.
Yeah. But I think Aiden is working on trying to consolidate all that stuff. So this is sort of a parallel approach where Aiden's working on the implementation side, the back end. This is sort of the use of
Right,
it.
but isn't what he's doing, wouldn't that be used by, but it would actually be used by the compilation environment. Like the compilation environment would ask the port library to give it the information as opposed to it deriving it itself, like causing it to call it.
Process reduction is going to live in port library.
Right.
We cache the result in the compiler target, and then the JIT queries the target wherever it comes from.
What we can do is when we create a new target, we can actually say, I want to ignore all these things that the port lib gave us and mask out those things. Compiler can choose to say, I think the port lib is giving me these answers, but I'm going to ignore a subset of them.
Oh, I don't think it has, like, if we're going to go to the model where you're going to be able to turn features on and off, it shouldn't be I turn off stuff that this CPU has. There's one way of generating the target, which is ask the port lib to populate the stupid thing from the processor. And the other one is stand back, I'm going to take care of this, right? Because you may wish to generate code that is not even going to run on the current target, right? You may wish to have the x86 code gen emit, TLE instructions on a processor that doesn't, TSX instructions that on a processor that doesn't have the TSX extension enabled. There's nothing wrong with having the compiler do that. It's just if you run the code, it'll fall over. But you can do that on GCC, right? I could be sitting on a Pentium 3 and tell it to generate AVX2, and it will.
So for context, up until last year, we've supported for compiled targets on Z, and we are able to turn off features which the processor currently supports. That's been hella useful when you're implementing new processor features and you need to debug on a per compile basis. So you have a bug in a certain compile, I'll turn off the feature on a certain compile and then rerun.
Right.
And I'll figure out whether the bug exists because of the new implementation or not.
Right. But I like that. Yes. Well, I mean, sure, we can have one that, is populate it and then modify it. But I mean, at the end of the day, if it's going to be abstractable, right, and you're going to have -M arch flags or -F, the equivalent of M arch flags or F feature flags, right, saying that, turn on SSE2 or turn off SSE3, you're going to need to be able to just sort of cook one up out of nowhere.
So I think both of these can be done in the same way. Like you query the port lib and either you remove features or you add features, but it could be done in the same place.
In that case, why do we need to query the port lib in the first place? If we've said what features we have, we don't need to go to the port lib at all.
Right. The arch, if you have arch levels, right, like what GCC has, that is essentially a statically built bit pattern that is, this is what the CPU does, right? And those ones, you don't need to call the port lib. It doesn't matter what you're running on. There's no reason to ask the CPU. It's just copy construct from this bit pattern or port lib, get me the real bit pattern, put it in here, and I'm going to dork with it. Yeah, it's kind of 6 of one, half a dozen of another, but it needs to support both modes.
So that works on x86, where I think you get handed back the results of the CPU. So what do we have on power, let's say? What comes, is there a bit
So
vector?
on power, we typically just use the level of processor. So power 9, power 8, power 7, and then we get it once at the beginning of the compilation, I believe.
Yeah.
And then we cache that. But there are a couple.
So you want to know
things
if you
that
want to
work
support the
differently.
square root instruction. Maybe that's not a great example, but support the square root instruction. It checks to see if you are
It checks to
Pentium
see.
3 or above,
Yeah,
and therefore.
are you at least P something?
Yeah. Are you at least this level of the power ISA?
Which I mean is probably not like from what Andrew's told me, even power is moving away from that mode where they want to be able to have features independent of the processor level.
With open power, the processor is.
But
Do a flavor of both.
Okay.
There are some instructions associated with a facility.
Okay.
There are some which are just not associated with anything, and they introduce a certain processor level.
Okay. So would a model like what is potentially being proposed here, where we just have a canned sequence of bits, let's say, could we get that to work in a Z world?
I don't see one.
I mean,
Because the capabilities, like the capabilities that are tested as capabilities are a bit vector, a bit,
vector, yeah.
and then the level is just
Byte.
a byte or whatever, and you set it to whatever number.
So you said both then.
So, yeah, generating those things is just copy constructing a bunch of bits.
Like you can probably just have this with a virtual hierarchy of like, here's the abstract thing of it's just one of these, right? And you can populate it from the port lib, and then each of the platforms has their own specialization because every architecture is going to have a different way of specifying which things are enabled or not.
I think end of the day, the compiler proper should not care where the information comes from.
Yeah.
It should just care what
Like-
interface it needs to
Yeah.
get it, and then whatever implementation decides whether to get it from the port library or from a file or whatever.
Because ARch64 and RISC-V are both much more modular ISAs even than x86, right? They're highly
ARM2 as well.
are highly capabilities driven, right? And they're going to have big bit vectors of I have core and I have this and I have that, but I don't have this and I don't have that, and you're going to need to toggle all that stuff on and off and make sure that you can compile for whatever the target is that you're actually targeting, because it's not uniform.
if we had this support, I mean, it also means that OpenJ9 is the one that has relocatable compiles, but anyone that wanted to, you could make it so that whatever's in the cache is the target that you target after that. So if you have multiple SECs, you read the target of the lowest SEC and you say, for any new relocatable compiles, I'm targeting that because it has to be consistent with the rest of the caches.
So I don't know if this happens at all now or not. And again, I think this is probably more of an OpenJ9 question. But are there places in OpenJ9 right now that are asking about the targets that are not part of a compilation? So outside of a compilation thread? Because if that's the case, then it would seem that that's problematic at the moment.
I saw,
Potentially a bug there.
I did see, well, it's not a bug as so much as it's in the virtual patching.
Well, it depends what you're doing with that information, I guess. But
Yeah,
like if you're
I have to go look. I remember searching for TR compiler target.
yeah.
There's like thousands of queries responses. There were some that were in. But this was target. I don't think it was going to CPU specifically. It was asking, I think, the passing logic probably because it needed to know something.
I think the best thing to do is just search replace tr compiler dot CPU with tr : comp and just see what fails.
Yeah.
So it depends. So are you thinking about just moving the CPU part of target out or the whole target? Because if there are legitimate questions that you ask of the target from outside of a compilation thread, that should apply to all compilations.
At first, I started just CPU. Then I don't know why. I said maybe it's better to go target because in the target, I was also asking questions like. Actually, I got to see what the CPU is asking, what the target's asking.
Yeah.
I remember moving target just because I thought, it might be similar amount of work. What's wrong? I think it's considerably more work. I can take a look and see what the queries that target answers.
Okay.
Because if it's maybe we can only get away with just CPU for now, and that'd be all that the compiler needs to care about.
Right. I mean, I would think that we would hoist CPU out of target altogether and have it live in a compilation thread.
Right.
Then you lose the ability to have a CPU for your host and your target. That's something we want.
I have to see if we ask.
Or you can, or if there's some way that you could prevent. So if you have a model where you have multiple compilation threads that could be generating code for different targets, what does it mean to ask the global compilation environment for the target? What answer would you expect to get back? And it sounds like we do have places where we ask that question right now. So how do we prevent that? I mean, certainly in some traditional compilation models, it does make, you can get a legitimate answer back because all my compilation threads are producing code for exactly the same processor. So therefore, you could ask a global environment for that answer.
Depends on the nature of the queries that are coming from the global, though, because at the moment we're not talking about cross-compilation to multiple different targets. What we're talking about is having the uniform target notionally, right? Like you're not going to change architectures, but we want to change capabilities. And depends if the questions of the target are of the nature that you can answer it without knowing anything about the actual CPU. It's just a property of that ISA in general across all machines. There is one single answer, in which case the details of what the CPU actually supports or not doesn't matter. Right, and those ones, like if the first step on this evolution is just to get that tactical level going, then I don't personally see why we would impose a higher overhead on Erwin or whoever from OpenJ9 wants to contribute the first step of the refactoring so that they can get what they want out of it. Right, it's one step closer to what we would like.
So it looks like at least in OpenJ9 there are few places like options that we pre-process where we'll do stuff like prefer TLH depends on the CPU, the actual target CPU. JIT-hook initialize send target. That one is another one where it does its heuristics counts are varied depending on things. There seem to be heuristic decisions that we're making.
I would imagine, based on just the ones you just said, that those are just very coarse-grained. Are you x86? Are you power or something like that?
It's suppose decimal floating point counts 0. Like it's heuristic decisions about like if the target supports it, then and your it's also in there. It's very coarse-grained. It's not doing anything like feature detection. It's like that's definitely not being asked outside. Although I mean, supports decimal floating point is sort of feature detection. Compile decimal methods containing DFP stubs right away, heuristics. So
Sounds like you want to pull the CPU out of target, out of the environment, and put it in the compilation.
Yeah, I mean, all the initialized set target is again that is an OpenJ9 is not.
Pending that there are no CPU queries outside of compilation.
Yeah, which there are. There's a few. Compilation thread, CVP has quite a few. Controller has some. I have to look at exactly what's there in OpenJ9, but I mean, for the OMR refactoring, that you can still have, at least for the refactoring, the first step, it can still be a global one that's copying instructions into the compiler to facilitate the move. And OpenJ9 can choose to use it or not. I don't think anything in OMR asks for it outside.
No, I mean, that would be, you'd have to look in either JIT Builder or
Right.
AFE test for an actual, something that's hooking up to the,
Which, I mean, I have them here and it's not showing up.
it's pretty,
Yeah. It's all within the compiler. So it's a compilation rather. So compile method. Oh yeah, it sets the default processor. Right, and then options, there's some queries like, are you 32-bit, are you Z? So some other stuff.
okay. So I think you could explore the localization of the CPU information. And I think by doing that, you'll probably discover some of the, or learn something from the uses outside of compilation threads that there might be issues that we have to deal with. We have to rectify.
But a lot of the uses outside of the compilation thread are not going to be things that are really affecting the AOT code, because they're decisions about what we want the runtime to prioritize, or what things we want to compile for the environment that you're running in, right? So we haven't separated that notion previously. It's all just being one big soup. If we're allowing the target to be overridden, like the CPU to be overridden, you're necessarily potentially allowing somebody to create code that isn't going to run in the process, right? So whatever the actual JIT and its associated runtime is going to choose to do in the context of the current process, if you've overridden it for a compile, it shouldn't change those decisions really, right? Because it's not like, if you're going to add capabilities or remove, like if you're going to remove capabilities, well, okay, sure, you might have prioritized compiling something that you can't hardware accelerate or something, but we usually have a fallback path for all that kind of stuff when it's capability driven. It was usually added at some point unless somebody deleted the support. And then you have the other kinds of queries which are really about what should I get running first, or what should I prioritize on this VM, in which case the kinds of things that you're talking about dorking around with are not things that you're really going to worry about.
Yeah, but the looks of it, most of it seem to be sort of heuristic setup decisions that are going to affect. It's just long term, I think. If you ever want to support cross compilation and stuff, some of these things are going to have to.
Oh, don't get me wrong. I completely agree. And there's a huge thorny software engineering and architecture problem around how to disentangle all that properly. But
the baby stuff should be fine.
Like we're talking, there's a strategic question here about how we pivot all of this stuff so that it all makes more sense. But there's also a tactical problem, and I'm trying. I guess my point is, let's focus on the tactical problem in the hope that it gets us a little bit closer to seeing the solution to the strategic problem. Because right now, I don't think any of us understand how we'd even decompose the strategic problem into a set of things that we could actually do.
One thing I'd like to avoid is having both a global and a target-specific CPU, because that's asking for a lot of trouble. People are going to use them interchangeably, and then you get into this weird bug world.
That's why the thing I was thinking of was it wouldn't quite work, because we have to add friend classes everywhere. But one way to stop that would be to make the CPU private. The only problem is lots of people still kind of need the CPU outside, and I don't want to add friend classes, which is ugly. So
I think we need to determine what places actually need the CPU information outside of a compile, and then reason about this.
But were you proposing, I thought that what you were proposing was that if you're going to do this, it's only going to be local. CPU is only going to be local to the compilation. You're not going to have one in the global.
So if you have a global and a local,
you can't even ask for
right.
in a global.
So I think we need to understand what are these locations which are asking for CPU information outside of a compilation, and is there a way to not do that?
yeah, I mean, yeah, right. The one I have right now is get default options. I'm sure that can be changed.
Right. So I think we need to understand what are the others.
Do we currently just have one CPU for representing both the target and the host?
No, each one has a CPU inside of it.
Lives in the environment.
But I think they're constructed the same way.
Okay, fine.
I don't know how many places we actually query host.cpu, to be honest.
I think there's like one. But it's not common.
Because from what you were listing, it sounds like maybe some of the ones where we're currently asking the target, maybe we should be asking the host.
Yeah.
Some of them, yes. But like for example, like the one that's having a get default options, they're applied to the compilation.
Right.
So it's like we're saying this compilation should have these options. That's
Right. Okay.
So, I mean, that's potentially a global options question.
Yeah.
But if different compilations can do different things anyway, then perhaps the global options shouldn't even be set there in the first place. It should actually be on a per compilation thread, should it? So maybe that's the wrong place for that.
right. I think most of these things could be made for compilation.
Yeah. I mean, a lot of this code is just coming from a historical world where there was just one target and you could get away with things like this. So.
And OpenGen is a bit easier because it's more focused. We're never going to have general problems that OMR has. We know exactly when the AOT code is going to run and what the circumstances are.
Right now, yes. I suspect at some point you might want that for JIT as a service, though.
But I think the way, so I was talking to Mark about this, and because unless we change the way we compile our JVM, our entire project, you can only ever have, you can't ever be like, I'm going to compile for both X and Z in the same process. We can't do that right now. Because of the iPad.
Right. Yeah.
That's a problem that's much farther away.
Yeah. But so the thing is, what you could imagine is, say, like, if you have a serverless application that's built with JIT as a service, and you have something that is running on, like, some IoT device that's running some version of ARM, and then at some point you decide that you want to, I don't know, you deploy a hardware upgrade, and now all of your devices have this extra encryption unit or whatever. And now you want your server to start generating code that takes advantage of that.
Right.
So in this case, you would be potentially serving multiple versions of the same architecture. And that's kind of an in-between where you're not really doing cross-compilation, but or rather you're not compiling for different
Right, but I think like, what I meant to say was I see what you mean. When I was talking specifically about AOT, because we would limit it no matter what. The AOT code generator.
For AOT, you're right. For AOT, you're right.
You're right. For JIT, it would. The thing is, the heuristics that are, so for example, in OpenGen and JIT was initialized end target. That's called once per method that's loaded. If you change your system and the process is still running, they're not getting changed. Their heuristics are set in stone unless you restart the server.
Right, which I guess you could do.
At that point,
want to have like recompile the server.
Yeah, I don't know. That's I guess there's two problems here. One is they can't look at the places in OMR. The follow-up problem would be look up in OpenGen afterwards. But okay, I guess I can at least start looking into it. It seems like a direction you guys want to go in.
Yeah. And I'll just reiterate what Philip said. I agree with that. That we could probably look at removing target on the global.
The entire target or just CPU? You mean?
Well, as you're going through it, maybe you can.
No, that's why I started doing target entirely. Target proper. There's a couple of places where.
What else is in target anyway? Sorry.
I think it's like operating system information, whether it's SMP or not.
Okay, that's not likely to change.
There is.
Or maybe it is.
So this one, Virtual Guard Runtime Helper. That's called. It's called. I think it's called at runtime.
Which one? Which platform?
This is. I'm just looking for this is the AR64. There's one for X2, I think. It's like underscore patch virtual guard, right? There's one for X as well. And that That doesn't query the environment, that just knows. Okay. So AR64 queries the environment, says, target.cpu.isTarget within conditional branch immediate range. It asserts that. Doesn't actually use it. So the code already assumes that it can do that. But point being, there's some places where target is called outside of the compilation. That I looked at it and I went, I'm going to deal with this afterwards when I started doing my search and replace.
Well, I mean, if we think that this environment stuff is not going to, if that's going to be the sort of the static bits, maybe CPU should move out of, maybe it should be target CPU or something like that.
Yeah.
Into its own.
In this particular case, it's like it is CPU that's being asked outside of the compilation, but
Right, but for like patch virtual guard, for example, if the answer, if the thing that's happening here is not a property of global or a property of the compile, it's a property of the thing that was compiled.
Mm-hmm.
Yeah.
Which is the
What target did we compile it to? Because that is where you get the answer from, right? It's almost like
You ask the method itself.
you need to ask the method.
yeah. Which means that the method would have to.
Sorry, what function? This is a patch virtual guard.
This is an AR64. So if you look at
What are they doing? They're probably looking for a specific instruction.
Well, the starting, it is in the start. It's actually not using it.
AR64 has that?
Yeah, just look up.
So why are we asking the target if it's within the branch range? Does it depend on what CPU features we
It's
have?
target.cpu is within.
Right, but is that even the right place to have that query in the first?
Because, well, so when we generated
that should be when you actually generate the virtual guard. You should be asking whether I can reach it.
Yeah, so they use their query to generate it, and then they're asserting that it's true.
Right.
Okay, I think this is the
It's just a useless assert. If it wasn't generated in range, then there's no way that you're going to patch it to be in range.
Yeah.
It might have been added as part of like their debugging when they first implemented it.
Right.
Right, but
This exists on every, I think it exists in every.
It exists in every one, but like for example in X there's no assert. X just does the thing. It's like
it does the patching based
It
on.
just does the patching.
Yeah, it just does the patching. It doesn't go and ask about.
that also just does the patching. It doesn't do any sort of doesn't check the target.
Have you magically moved from your previous location in memory so that you're now closer?
So, I mean, these are the kinds of things you're going to come across.
Yeah.
Like some of these could just be.
I think we should go through the exercise.
All right, I already started doing it, and then I stopped because I was like, this is really tedious. Because I wasn't doing TR going comp because I figured that'd be expensive.
I think a definite goal should be not to have two places where we could potentially ask this thing.
All right.
But sorry, just to warn you, if you use tier comp, you may not always get compilation thread because if you are in your options code, for example, before the compilation,
exactly.
you're not
get
going
the
to
dummy
get
one.
that.
Which is why I was.
I don't think you're even going to get that.
Yeah.
It's not set. And some threads don't have it set at all, right?
Right. Okay.
Which is why I mean I can just go down the tedious path. It's a couple of hours. It's fine. I just didn't want to continue.
Expect your pull request by 5 o'clock.
I just didn't want to continue.
Comics. So how many words are going to you type?
So then, I'll like between target CPU and target, like I think target is like 2 orders of magnitude more instances, so that's why I stopped. But if you want me to do target, I can just start doing target and then open something afterwards.
I think the only way that we're going to know the full magnitude of the entanglement is to have somebody actually go and do the doing.
Okay, now let's clarify that it's target and not target on CPU, right? The entire target you want to move to the compilation, as asked by the PR that I opened, or the issue that I opened.
Well, I think the answer to that question is partly how much work you're going to have to do and how much work you're going to contribute to the project in doing it. If the thing that you need is the CPU primarily, and you cannot, for whatever reason, provide the time to do the target because it's some Herculean thing or there's some really ugly thing about it that needs deeper work, I don't think that the project should reject outright the possibility of you moving CPU as step one of moving the target. But if you can do the target as a whole, then that would probably be cleaner and nicer and probably be less confusing for people. So if you can do that, that would be fantastic. But
I started off at the 20 plus files I went through. It didn't seem like it was that hard.
Yeah.
I never hit. I hit this thing, and you like this is one of the judgment calls where I stopped, but you guys are like at the point of start, so we can remove it. It'll just become one of those things where I'll have to bring it up in a PR and issue and just say, here's what's remaining. What do you guys think about all these places, and then act accordingly. Fine.
I don't see why there's a problem with that. Right. And some of them may end up in the category of it's not really the target or the host. It's the thing that you actually are introspecting. What the hell was that? In which case, the bits or whatever it is that we're using to store this representation may need to end up in the persistent method body info if we really need to ask that question. Because if they can be polymorphic in terms of what they support, the answers that come back need to be polymorphic in what it was compiled to. Right? And there's no way to avoid
Which
that.
is something that's very useful because today we have no way of telling what a JIT body was compiled against.
And given that you now support configuring it for the purposes of debugging, it would be helpful to know in the core file what the hell it was actually configured to be. I am running on a Z15, but this was compiled for System 390 per 1972
Yeah, I mean, today we know what instructions are most likely to get generated on the target. So just search like 300 methods for that instruction.
I see we're using.
Try to guess which.
The heuristic target guesser. Yeah, we should definitely bake that in.
All right, so I'll continue then. Yeah,
Okay.
But it may even make sense to think about putting those bits into the method info.
If we can have a small enough bit, like if the bit vector is like it's a few words, that's not bad.
Yeah, exactly. That may be justifiable. For the sake of everybody's sanity. If these can really be polymorphic, and you're really going to have AOT methods in the cache or whatever that are configured for a particular target, okay, maybe the header of the cache knows something about what the overall scheme should be, but at least knowing exactly what the compiler was running with.
Actually, it wouldn't even be that bad. You could even hash it, right? You could because most you're not going to have every method be.
I'm not even going there. If you want to come up with some crazy abstract mangling scheme, you go right ahead.
You have a table of a few. It'll most likely be 2 or 3 different variants of processes. You're not going to have every method is just going to be a subset of whatever features you want, right? In which case, you instead of if for example in AR64 RISC-V, you're saying the bit vectors can be really big. Instead of every method storing the same bit vector, you just sort of say index 1 of table of features.
Configurations.
Yeah, and
you could stick that. You could stick a configuration pool. Yeah, the configuration pool.
So, anyways,
first things first.
We're going to over-engineer that solution.
Let's start with this one.
Okay. Any more discussion on this topic? Okay. All right. Thanks, Erwin. And if there's no other business, we'll close the call for this week, and we'll pick it up again next week.
How much time do we have? I just wanted to bring up something. But
we have 7 minutes.
Another rabbit hole. I don't know if you want to go down it, which is the UINT PTR-TJ. I don't know if you want to have a proper discussion for that or just. I don't know you said you want to think about it, but then I never.
I trying to remember what I was trying to think about, but actually, no, I think the last question that I remember you had asked about that was, what is the best way to approach the refactoring of it? And I think it was Gak that said.
Gak said get rid of it.
No, I think he said start from scratch. And I think that there have been so many inconsistencies introduced in the code base since we had used this, probably literally 15 years ago was the last time it was properly used, that it probably just makes sense to start from scratch and think about every place where you use host, where you use target, where you use UINT PTRJ, where you don't use UINT PTRJ.
Well, so I think with Gak, after we agree, my understanding was he said if we wanted to do cross compilation, we should start from scratch. And for now, just make them consistent so that it's one type.
Yeah, I thought that was what he implies.
If you wanted to use one, if you just make it all,
make it all like the standard one, which is not the J one, the T.
Yeah, which
is
the standard C++.
He said, when we want to go to cross compilation, that's when you. Sorry. thinking about what to do.
Yeah, you can make it consistent, sure. Yeah,
Okay.
it doesn't make it to me. It doesn't make any difference right now. It's just it's broken.
All right.
Yeah.
So that's part of the problem because everybody thinks that way. Oh, these things are the same. I just use whatever one.
Well, that's sort of why I looked at it in the same file, the two lines had different ones. And
Yeah.
I'm like,
Oh,
Well, as long
So
as we have no
related.
way of checking that people have done it correctly, people are always going to screw it up. at
Yeah.
some point.
yeah. So related to this in some way is, and I wanted to open an issue for this, or maybe even just a PR, is there's an object model query called size of reference address. And the intent of that API is to answer what is the size of a reference on this target. And the answer, for example, should be 8 on 64-bit unless you're using compressed references, in which case it should be 4. But I think it's always returning 8 on 64-bit, and people are using it in contexts where you're not asking about a reference, you're just asking about the size of a pointer on this target. So it's being used incorrectly. So I think, and there's gazillion of these queries all over the place. So in some cases, it should just be a size of int ptr underscore t, as opposed to asking the object model, what is the size of the reference address? So there's some serious work, I think, that needs to get consistency work that needs to be cleaned up there, but it's kind of related to your,
Okay.
to this thing.
So I have to go ahead to, when I have time, just do a search and replace.
Yeah.
Okay. I've been wanting to get rid of it, because I mean, I have to do it on both OpenGN and OMR, and hopefully no one else outside of it is using it too, but hopefully they're using PTRT. And
Yeah.
good.
I don't know what you've done in Lua or whatever, or even WebAssembly, if you've actually done any of that, but
no.
there might have been the odd one that popped up. I don't know. If somebody copied some code from somewhere, I don't know.
Not as far as I'm aware. Every project I've looked at, they really need to, they use in PTRT.
But what we can do is deprecate it in, let's say, our OMR release, and
Right.
then, you know, we have some kind of an assert or something that comes out when you.
There's no reason
There
you
were
couldn't
ways
make
to
a
hash define with like a.
I think the linter can have it.
Yeah, you could just
Pound
ban
define.
just ban it in the linter.
Yeah.
If you touch a file that has it in, it'll complain, and you have to go clean it up.
We could pound define int ptrj underscore t to pound
Please
error.
please don't do that. No. We don't need more macros. There are too many macros.
Temporary until we deprecate it the next, actually remove it in the next one. So.
No.
All right. All right. Okay. Anything else you guys want to talk about? Okay. All right. Thanks, everyone. Talk to you next week.